Hello everyone, in the graph part 1 we have seen what is a graph, concepts involved in graph, and in that we have learned that there are 4 different methods that we generally use to represent a graph in our program. And these 4 methods are: first one is adjacency list, second one is adjacency matrix, third one is edge list, and the fourth one is implicit graph. These are the 4 different methods that we generally use to create a graph. And in the last session I have shown you how we can create a graph in the program using the concept of adjacency list. Now in this session what we're gonna do is that we are gonna talk about different graph traversals, techniques / algorithms, and we are gonna talk about a concept called as connected components, and after it finally we will talk about what are the cycle detection algorithms that we use to detect whether a cycle is present in the graph or not. These are the 3 things which we are gonna do in the whole session, in this session. So talking about graph traversals, before we dive into what is graph traversal, how we perform it, what are the terminologies involved in it, let us recall some concepts. We have studied trees. So in trees, let us say that this is a tree I am having, this is the tree I'm having. Okay, so in trees, in tree traversal, if I talk about tree traversal in specific, we have 2 different types of tree traversal techniques. The first one is level order traversal, in which we use a queue data structure and we will iterate level wise, and as I iterate level wise I will add at that particular level whatever the elements present in that level, I will take that and I will add those in the queue, and like this I will iterate through each and every element, and as I iterate through each and every element I will remove the elements in the queue. This is what I generally do in the level order traversal. And the second type of technique which we generally use to perform tree traversal is pre-order, in-order, and post-order traversal, and these are recursive based techniques. This is recursion based techniques. In this we use the concept of recursion, and in this we don't travel level wise, we go into the depth of the tree. Okay, similarly in graph we have 2 traversal algorithms. The first one is breadth first search, and this algorithm is very similar to level order traversal. So in trees we perform level order traversal, and the same logic, the same approach, whatever the things we did, we basically do in this algorithm, but we have changed the name, that's all. We have named this breadth first search, and it is very similar to level order traversal. And the second type of algorithm which we use is depth first search, and this algorithm, as I said, as the name says, going into the depth of the graph. So here this algorithm is very similar to pre-order, in-order, and post-order algorithms, and in this also we use recursion, and in this we use a queue. Okay, I will talk about in depth how these algorithms work. I will tell you the overall working and the pseudocode of this algorithm, but for now you need to understand that these are the 2 general techniques, general algorithms which we use to travel the given whole graph. Okay, now let us talk about what are the terminologies involved in it. So in tree, if I take a tree, let us say that this is the tree I am having. In a tree I will have a root and I will have leaf nodes, and my iteration will happen from root node to my leaf node. In this flow, in this direction, my traversal, both level order and the second recursion based traversal, will take place. Okay, but the problem with the graph is that I don't have a root, I don't have a destination, leaf, I don't have any of these 2 things. So what is the flow? How I can iterate? How I can iterate in my graph, and from where I should start my iteration? So to answer that, and one more thing you need to remember is that in trees there is no cycle, there is no concept as cycle. Let's say you are starting from root node and you will come down, and you will never encounter the concept of cycle, formation of cycle in trees. But in graph a cycle can form. There is a probability that a cycle can be formed in the given graph, right? So we need to think some processes, we need to place our systems in such a way that we should not iterate an element more than once. Right? My goal is that in trees, let us say that this is the tree, I am having 1, 2, 3. Now when I perform tree traversal, I will not repeat an element more than once, right? I will print 1, 2, 3 as my output. And similarly, when I want to perform a graph traversal, for this my approach should be, I should print an element only once. And in order to print an element only once, I should introduce some concepts, some processes in place which keep track of my visited element. So again, I need to consider what is my root, what is my leaf node, and I need to give some direction to my graph. Not direction, you can say a flow. From where should I begin and where should I end? So I need to give this, and along with this, I should not repeat an element more than once. So this graph traversal will print the element like this: 1, 2, 3, 5, 4, 2, 6. I should not repeat more than one element. Okay, so repetition in graph traversal is not allowed, and for that we will introduce a concept called as visited, boolean visited. I will create an array of my number of nodes, size, and initially I will store at each and every index of my visited array, I will store false, and as I move each and every element, I will make that in that array, I will make at that particular index, I will make that visited as true. And if that element is true, then I will not go to that element again. I will show you in diagrammatic representation. I will show you. It might look complex, but if you understand, it will become very easy. Okay, so here in tree we have a root, we have a leaf. Similarly in graph we have source and we have destination. Source is the first element in the graph which you have added, and destination is the last element in the graph. While you creating the graph, the last element which you have added, that element will become your destination. And the main goal is to print whatever the elements which is lying from the source to my destination. Whatever the elements lying in between this, I need to print those elements. This is the meaning of graph traversal. I hope you have understood. So what I will do is that I will initialize all the elements. I will create a boolean type of size v, and all the indexes are assigned with 0. So this is the indexes, right? 0, 1, 2, 3, 4, 5, 6, and this visited array, boolean visited array, will keep track of a element, whether that element is visited or not. Okay, and this is used to avoid repetition. By using this concept, we can avoid the repetition of elements. So here I will create a boolean type array, and this indexes will represent each and every node in my graph. Okay, and all the nodes are initialized with false. So here I will initialize it false, false, false. All the elements are initialized with false. Okay, now I will go to my source node. This is my source node and I am here. Okay, now I will print my source node. In the output screen, I will print source node and I will make this as true. Now I will go to the next neighbor. The next neighbor is 1. So I will print 1. After that I will make this thing as true. Now again I will go to the next neighbor, that is 3. I will print 3 and I will make this visited from false to true. Right, now I will come to here in this position and I will print 4 and I will make this as true. Now from this I will go to this position and I will print true 2 here, and from false I will make this to true. Now here you can see that I can't go back to 0 because the visited of 0 is true. If it is true, then I can't go back to the same element because I don't want to print a same element again and again. Okay, so what I will do is that instead of going to this, I will go to this position and I will print 5. After that I will go to here, I will print 6 and I will make true, true. So all the elements, finally after graph traversal, all the elements in the visited array will be assigned with true. Like this I will perform my overall operation. This is the overall idea of how we perform. We introduce a concept of source and destination, and whatever the nodes which are lying from the source to destination, I will print those elements, and I will keep track of a visited boolean array, which will keep track of whether a particular element is visited or not. If it is true in that particular index, if the element, in that particular index, if I am having true, then I will not go to that element. If it is having false, then I will go to that node and I will change its visited from false to true. This is the overall idea. What are the three things? Source, destination, visited boolean array. Source and destination are used to print the elements, and visited array, boolean array, is used to keep track of the number of elements, and it will avoid repetition of elements. I hope you have understood. Now let us talk about breadth first search algorithm. So in breadth first search, I have said you that this is very similar to level order traversal. So in level order traversal, what we did, this is my tree and I will go to level wise. Similarly, in graph, I have a source, I have a destination. This is my source and this is my destination. So what I will do is that I will break down my graph into different levels. So this will become my level 0. And for the source node, whatever the neighbors connected with it, that thing will become my next level. So this will become my level 1, this thing will become my level 2, and level 3, level 4. This is how I will break down my graph into different levels. Now the approach of BFS is go to immediate neighbors first. Whatever the node you are at, print that node or add that node into the queue, and after it go to the immediate neighbors. Whatever the neighbors this node is having, you should go to their neighbors. So what I will do is that approach, I will talk about the directly approach. After that I will show you a dry run how this will work. So what I will do is that first of all I will create a visited array, and this array assign all the nodes with false. So here visited of 0 will become false, false, false. Like this, all the elements are assigned with false. Now the second step will be I will create a queue and I will add the source into my queue. So here I will add 0 into my queue. So I will add 0 into my queue. Now after adding source, I will perform the third step, that is whatever the front element, this is the front element, right? So whatever the front element present, take the front element and add all the neighbors of that front element. So add neighbors of the front element into the queue. So here you can see that for 0 the neighbors are 1 and 2. So I will add 1 and 2 into my queue, and the fourth step will be remove the front element. After adding the neighbors, remove the front element from my queue. So here this is the queue I am having, right? 0, 1 and 2, and this statement will be in a loop. Put this in a loop until you have iterated all the elements. Until you have iterated all the elements, this loop will continue, this process will continue, this 4 steps will get continued. Okay, now first of all I have added 0 into the queue. After adding, for this node, for this element which is at the front, you can see that this is the front element, right? So for this front element, what are the neighbors? 1 and 2. So I will add 1 and 2 into my queue. Okay, after adding 1 and 2 into my queue, I will remove 0, and let us say that this is my output screen. So in the output screen I will print 0. Okay, now my queue will become 1 and 2. Now I will make, for 1 I will make this as true. Now you can see that for 1 its neighbor are 0 and 3. For 1 node the neighbors are 0 and 3, and I have already visited 0. So I will not add 0 again, I will add 3. So I will add 3 and I will make 3 as 3 visited from false to true. Okay, now after adding 1's neighbor, I will remove 1 and I will print 1 in the output screen. So my queue will become 2 and 3. Now for 2 they are two neighbors, that is for two node there is 0 as one of its neighbor and there is 4. Now 0 is already visited, so if it is visited then I will not add that into my queue again. So I will add 4 in my queue, and after adding I will remove 2 and I will print 2. Now my queue is something like this, 3 and 4. Now for 3 the neighbors are 1 and 5, and 1 is already printed. 1 is, I have already visited 1, so I will not add 1 again, I will add 5 now. So I will add 5 into my queue. After that I will remove 3, I will print 3. Now now if you observe the queue, my queue is something like this, 4 and 5. Now for 4, its neighbor are 2 and 5, and 2 is already visited, 5 is already visited. So for a given node, if all the neighbors are visited, then don't do anything, don't add anything, just remove that element from the queue. So I will remove 4, I will print 4. So my queue will become 5, and for 5 its neighbors are 3, 4 and 6, and 3 is already visited, 4 is already visited. Now what I will do is that I will add 6 into my queue. So I will add 6, I will remove 5. Now the only one element present in my queue is 6, and for 6 its neighbor is 5, which is already visited, its visited is true, so I will not add it again. I will remove 6 from my queue and I will print it, and you can see that I got the output. This is how we perform BFS. For a given node I will check whether it is visited or not. If it is visited, then I will not add it again. If it is not visited, then I will add that element into the queue. After adding element into the queue, I will check for this element which is present in the front of my queue, I will add its all neighbors, and this adding will only happen if for all the neighbors for that particular neighbor node, if it is visited of that node is false, then and only I will add, else I will not add. I hope you have understood. And after adding the neighbors, I will delete the front element and I will print that in the output screen. This is the approach of BFS. Now let us code this thing. So in the program, first of all, I have imported java.util.star and my universal class, and in the universal class I have created the edge. In the edge I am having source, destination, weight for all the node. Each node will have these three things. Okay, now after that I have created a function called as create graph. So basically what I did that in the previous function I have created my graph, right? So I have took the same graph and I have put it in a function, that's all. So in this function I am creating a graph, my graph, and this is the graph which I have created. Now let me remove this. Okay, now in the main program I have assigned the number of vertices are 5 and I have created my array list. Now I have called my create graph function, and my create graph function will create my graph. Okay, whatever the graph I want to create, this function will create it. Now what I will do is that I will write a function static void BFS. In this I will pass my array list of my edge. I will pass my graph here. I will pass my graph here like this. So after passing graph, what is my first step in the function? First of all, I need to create a queue. So I will create queue of integer queue is equals to new linked list. Now after creating queue, I will create a boolean visited. So boolean visited array is equals to new boolean, and the number of indexes in my boolean visited will be graph.length, because I am storing at each and every index I am storing the node visited value. So the total, whatever the total number of nodes present in my graph, that thing will become the size of my visited array. So graph.length. Now after it I will add the source element, that is 0. Q.add, I will add 0 because this is my source, right? This is my source element. I have added the source element. Now I will run while q.is empty, is not empty. If this is not empty, then I will take the current element. I will remove whatever the front in the front of the row, whatever the element is present. First of all, I will remove it. So current is equals to q.remove. Now if that particular element is not visited, if that visited of current is not true, then what I will do is that I will print that element first. So I will print cu order and I will give a space like this. Now I will make visited of current as true, right? So I have visited this element, so I will make this as true. Now after that, the rule says that go to immediate neighbor. So again I will run a loop and I will call for all the neighbors. So int I is equals to 0 and I should be less than my graph of current dot size, and I will increment I plus plus, and in this I will write edge E is equals to graph of current dot get. Whatever the destinations I am having, I will take for this node. Whatever the neighbors I am having, I am getting that neighbors. So I will write q dot add. I will add this node's neighbor. So q dot add e dot destination. This is how I will perform my BFS. Now in the function, I will call my BFS function. I will pass my graph. So let me summarize what I am doing. The step 1 is I have created a queue. The step 2 is I have created a visited boolean array of size graph dot length, and initially all the elements are assigned with false. Now the first step in the iterative process is I have added my source node into my queue. Now after that I am running my loop while my queue is not empty. First of all, I am removing the front element and I am storing its value in current, and if that current element is not visited, then I will print that element and I will make sure that the current visited is true now. Now after making this true, my BFS says that go to all immediate neighbors. So in order to go to all the neighbors, I am running a loop, and in the loop I am adding its neighbors into my queue, and this process will continue until I have iterated all the elements in my graph. I hope you have understood. I hope you have understood the overall approach of BFS. Now if I run this code, then my output should be 0, 1, 2, 3, 4. Now let me save and run this. You can see that I got the output as 0, 1, 2, 3, 4. This is how BFS, this is how we implement breadth first search in our program. Now let us talk about depth first search. Depth first search is very similar to pre-order, in-order and post-order sequencing. So in this, what we used to do, we used to use a recursion technique, right? We used to use the concept of the recursion. Okay, so this technique says that go to immediate first neighbor. In the previous example, it says that go to immediate all the neighbors. Whatever the neighbors you are having, go to that, print those neighbors. Like this you will continue. But in this, it says that go to the first neighbor. Whatever the neighbor you are having, go to the neighbor. So the approach of this DFS technique will be, first of all, I will create visited boolean array, and secondly, this is my source node, right? This is my source node and my destination node, right? So first of all, I will assign current is equals to source node, and the third step is print current node. Now after that, the fourth step will be recursively call, let us say that DFS is my function. So I will call my DFS for the edge, for this neighbor. So immediate neighbor, whatever the immediate first neighbor I am having, I will call this. I will call DFS function for this. Now initially the current is this. So in the output screen, first of all I will print 0. Now after printing 0, after printing the current node, I will recursively call for this part. Okay, and I will make this as true. Now all the things are assigned false, right? And this DFS function is only get called if the visited of that neighbor is false, then and only I will call, else I will not call that element again. Okay, so all the elements are assigned with false. Now one is not visited. Okay, so because one is not visited, I will recursively call 1 and I will print 1, and after printing I will make this as true, and this function will call 3 and I will make this as 3 true, and I will print 3, and this will call 4 and I will, for 4 I will make this as true and I will print 4, and this will call 2, right, and I will make true visited as 2 true, and this will call 5. Like this, recursive function will get continued until I visit all the nodes in my graph. This is the approach of my DFS. What I am doing, first of all, I am creating visited boolean, and first of all I am assigning my source node as current node, okay, and after that I am printing my current node, whatever the current node might be. I am printing it. Now after printing the current node, I am recursively calling its first neighbor. For 0, its first neighbor is 1, so I will recursively call for 1. And now for 1, my current node will become 1. Okay, so if current node is 1, then I will print 1, and after that it will call its corresponding first node. So for 1, its corresponding first node is 3. Okay, so I will call DFS function for 3. Now the current node is 3, and if the current node is 3, then I will print 3 as my output. After that I will call for the rest of the graph recursive function. I hope you have understood the approach. If I code this, when we code this thing, then it will become very much clear to you. But this is the overall approach. Now let us code this thing. So in this, first of all, I will call my function public static void and DFS. In this, I will pass my array list of h and graph. I will pass my graph, and again in this function I will pass my visited array. So boolean visited array, I will pass boolean along with it. Now what I will do is that, first of all, if my current element is not yet visited, is false, then what I will do is that I will print, first of all I will print my current element and give a space here. Now after printing the element, I will write visited of current. Visited of current is equals to true. I will make this as true. Now after calling, I will go to its immediate first neighbor, and I will call DFS for its first neighbor. So I will write for int I is equals to 0 and I should be less than graph of current dot size. Right here, let me give pass current also. Here also in the parameter I will pass current, int current node also. Okay, now if this is the case, I will run a loop and I will call its neighbor, immediate first neighbor, he is equals to graph of current dot get element. Now after getting element, I will check for its immediate. If visited of e dot destination, which is nothing but for this node, its next neighbor, it is the e dot destination. If it is not true, then what I will do is that I will call DFS for the same graph, but the current node will become e dot destination and same visited array. Like this I will do. Here let me remove this and make the parenthesis a little good here. Okay, now in the main program, in the place of DFS, I will call my, in the place of BFS, I will call my DFS. So I will write DFS. Here I need to give DFS. So in the place of DFS, I will pass my graph, and my current node will be my source node. In this, my source node is 0. So I will pass 0 here. Now after that, I will pass a boolean. So new boolean of size v, because my size will become total number of vertices. Now if I run this code, then my output will be 0, 1, 2, 3, 4. So let me save and run this. Here I need to call DFS, not DF. Okay, now let me save this again and run. And one more thing is that statement terminator. Again save and run. So you can see that I got the output as 0, 1, 2, 3, 4. Like this I will print my elements using depth first search. I hope you have understood. And this is the code for DFS depth first search, and this is the code for BFS. Now I hope you have understood the two different approaches that we generally use to perform traversal in a graph. Now let us talk about a question related to this concepts. The name of the question is has path. So in this, user will give me a source and destination, and I need to tell whether there is a path that exists between the source and the destination. If the path exists, if it is yes, then I will return true. If it doesn't exist, then I will return false. For example, in this you can see this is my source node and this is the given destination. Okay, user has given me these two things. Now you can see that I can move from 1 to 2, 2 to 3 and 3 to 5. So like this I can go from my source to my destination. This can be my path 1 and this can be my path 2 and this will be my path 3. So for this given graph, there are three different possibilities, three different paths that can be possible to go from the source node to the destination node. Okay, now I need to check only one. If there is a path, irrespective of how many paths are there, if there is at least one path, then I will return true, else I will return false. Okay, this is my overall idea of this question. Now how I'm gonna check, and when is the case, when will I get a case where there is no path that exists? For example, let us consider there is a graph something like this. Okay, and this is my source, this is my destination, and this is my source. Now I have this is my single graph in which there is no edge, there is no connection. This is known as a component. The graph is divided into different components. We will study in just few minutes, but we call this as components. In the given graph, the graph is divided into two components where there is no a connected edge between two corresponding nodes. In this case, I will return false. Okay, now let us talk about how we're gonna do this question. So we are gonna do this question using the concept of DFS. We have studied DFS, so I will use DFS and I will modify DFS a little bit, and by just performing a very little modification, I can solve this question. Now let us talk about the approach of this question, how I'm gonna do this question. So what I will do is that, talking about the approach, I know that user has given me a source node. So what I will do is that I will apply DFS for my source node. Let me remove the thing here. So let me remove this. Okay, now user has given me source. This is my source. So what I will do is that I will immediately check if source neighbors is destination, whether they are destination or not. If the given neighbor, whatever the neighbors I am having, if it is the destination, then I will stop my loop, I will stop my recursive function call and I will return true. If this thing, if the neighbor is itself destination, then I will return true immediately, else I will go to the second step, that is call recursive function, recursive function for the corresponding neighbors. And the third step will be if all the nodes are visited, and I didn't get my destination, then I will return false. This is my approach. This is what my approach is going to be. So initially I am at my source node and this is my destination, right? So what I will do, first of all, I will call and check whether the neighbor which I am having, the neighbor is 1. So for 1, I will check whether this is destination. No, it is not destination. If it is not destination, then this 1 will call 3 and this 3 will call 5, and until I get a destination node, this recursive function will get continued. Okay, and I will iterate through all the elements, and if I didn't find the destination, then and only I will return false. This is the approach of my question. I hope you have understood the overall approach of this thing. So if you wanna understand this in layman's term, then I can give you an example. Let us say that this is you, the source is yourself. Okay, now you want pen. You don't have a pen in your hand, you want pen. Okay, so what you will do is that in a class, you are sitting in a class. Okay, now there is a person beside you. You will ask him, do you have pen? And if he don't have pen, then you will say him that ask your next friend, whoever sitting you next, ask him. So that friend will ask some other person, and if that person don't have pen, then he will ask some other person. Okay, and if he has pen, then he will return true, and this second person will return true, and finally you will also return true. So what I mean by this is that this is the destination, so I am checking whether this destination exists or not. Okay, now first of all I will call a recursive function for the next element. So the next element is 1, so I will call 1 and I will check whether you are my destination, and it will tell me no, I am not your destination, but I will help you in checking your destination. So this 1 will call 3, and this one will ask whether you are the destination of source node, and it will say no, I am not the destination, but I will also help you in finding the destination. And this 3 will call 5, and this 1 and 3 will call 5, and it will ask whether you, the node, whatever the node you are, whether you are the destination for the source node. And this 5 will tell me yes, I am the destination, and if it tells me that I am the destination, then this will return true to 3, and this 3 will return true to 1, and this 1 will return true to 0, and if I am getting true to 0, then I will return true to my output screen. This is the overall approach of this question. Now let us code this thing. So in the program, what I'm gonna do is that I will create a function static. Let me increase this. So I will write a function static boolean type function. So I will write this as boolean has path, and in this I will pass my array list of h graph, and I will pass my source destination into destination and my boolean visited array. So boolean visited. Now what I will do is that I will check base case, that is if my source is itself destination, if my source is itself destination, then I will immediately return true, right? If this is not the case, if this is not the case which I am getting, here I need to give, okay, if this is not the case, and here I need to give small if. Okay, it is showing some kind of error. View method, void method. Okay, static boolean, public static boolean type function. Okay, this is a parameter. Okay, now we will check visited of source. I will make this thing as true, and I will check for the next element. So for int I is equals to 0, int I is equals to 0, and I should be less than graph of current node, whatever the current node I am having, that is my source node dot size and I plus plus. In this what I will do, I will check h e is equals to graph of my source dot get ith element. Okay, now after it I will check for e dot destination. E dot destination is my neighbor, right? So for neighbor I will check whether it is, if visited of my neighbor, that is visited of e dot destination is false, and has path function for the graph and e dot destination and destination visited array. If these two things are true, then I will return true, else I will return false. This is what my approach is going to be. What I am checking, first of all I am writing my base case, that is if my source and destination are same, then and only I will return true, else I will run a loop, and in the loop I will call for the next neighbor. I will check whether it is unvisited. If it is unvisited and it has a path, it has a destination which is in it, if these two things are satisfied, that is visited of that particular element is false and has visited is returning true. If these two things are satisfied, then I will go into my if statement and I will return true. If this is not the case, then I will come back, I will come out of my loop and I will return false. Now here in the place of DFS, let me pass hash path. So hash path, I will pass my graph, and let us say that this is my source node and my destination node as 3. So I will pass my destination as 3. Now in this function I will pass my boolean array, new boolean of size v. Now if I run this code, then this code should return me true, because there is a path between 0 and 3, that is destination node and my source node. So let me save and run this. So yeah, one more thing, as I whatever the value it returned, let me print that also. So here I will print this values also. Let me save and run. So you can see that I got the output as true. This is what I'm doing. Now if I pass some node, let's say 10, which is not in the graph, then this should return me false. So let me save and run this again. You can see that I got the output as false. So this is how I will calculate whether a path in my graph from my source node to my destination node, whether the path exists or not. This is how I will calculate. I hope you have understood. Now let us talk about some other concepts. In graphs, we have a concept called as connected components. And what this connected component says is that, for example, let us consider 3 diagrams. I am considering 3 diagrams. Let us say that I am having diagram 1, something like this. Okay, and okay, this is my diagram 1, and the second diagram is this one, and the third diagram is this. Now my question is the given first diagram is a graph? Yeah, the given first diagram is a graph. Now the second diagram, whether the given second diagram is a graph or not. I have told you that in the first session, basically a given tree is a graph. Whatever the tree might be, right? It is a graph. From the concept of graphs, we have extracted the concept of trees. So whatever the given tree might be, it will satisfy the properties, the conditions of graph. So the given second diagram is also a graph. And the third diagram, in the third diagram, if you observe it, there is only one node, there is only one vertex, and it is not given that in graph, if we are only having one node, one vertex, then we shouldn't consider it as a graph. There is no rule like that. So the third diagram is also a graph. Now my question is, in the screen, how many graphs are you observing? You might say that, oh, there are 3 different diagrams, and because of these 3 different diagrams, there are 3 different graphs in it. Your answer is there are 3 different graphs in the diagram. And I will say that your answer may be true, may be correct, or it is wrong. Right? How? You can ask how. You can say that, oh Jabir, we can clearly see in the given diagram, in the given screen, I am observing 3 diagrams. And if you are saying that these 3 are graphs, then the total number of graphs in the screen will be 3, right? But according to the concept of connected component, there is no condition that the edges should be connected, right? So we can consider these 3 graphs. Instead of 3 different graphs, I can consider this as a unit graph, as a single graph in which they are 3 different components. 3 different components we are having in the graph. Okay, I hope you have understood. I hope you have understood the overall concept of connected component. Okay, so in graph we don't have any conditions that the nodes should be connected. It can be connected or disconnected, it doesn't matter. So you can consider these 3 different diagrams as a single graph. I hope you are getting it. I hope you are getting it. And the number of components in the graph are 3. Right? This is the concept of connected components. And one more thing is that if we introduce the concept of connected components, then one thing is going to change. that is we have studied BFS TFS, right? So we have done BFS and DFS for a single graph. So if the graph is divided into different parts, if the graph is divided into different parts, different components, then my general BFS and DFS will not work. What I can do here, my DFS and BFS is not working. So what I will do is that I will modify my BFS and DFS, right? So what I will do is that I will break down my BFS function into two different parts. So whenever I am encountering my component, whenever I am encountering a condition of component where a graph is dividing into different pieces, different parts, then I will modify my BFS. And modification is very simple, a little change, that's all we are doing. So here I will create two functions. The first function is BFS utility function, and in the utility function what I will do is that I will copy paste whatever the code which I have written in the BFS function. I have written some code, right? So I will take that function, I will take whatever the things I have written in the BFS function, I will copy that and I will create a new function called as BFS utility, and in that I will paste it, right? And in the second function I will create a function called as BFS. In this I will run a loop. First of all, I will create a visited boolean array, same, and the second step will be I will run a loop for I is equals to 0 to all the elements in the given component. Let's say in the given components the number of components are 3, but the total number of nodes are 10. So I will run a loop 10 times and I will call for 10 nodes, I will call BFS utility function. Okay, and if that node is not yet visited, then I will call utility function. This might sound complex, but when we code this thing, when I show you the code of this, it will become very easy to understand. Okay, so I will run a loop for all the nodes, and if the visited of that particular element is false, that is if it is not visited, then I will call my DFS or BFS utility function. This is what I'm gonna do. This is the approach. For example, let us take example. I'm having 1, 2 and 3, and I'm having another component 4. So this is my single graph. So what I will do is that first of all I will write false, false, false for all the nodes. Now I will come here, I will check for this node whether it is false, whether the visited of I is false. Yes, if it is false, then I will call my utility function, BFS utility function, and this utility function will run a loop, will do basically the same thing which we have done before. In BFS function, what I have written, I will same copy paste that thing in BFS utility. So I will make this thing as true and print it. After it, true, print it, true, print it. Now BFS utility will come back to my second function. Okay, now here I will check. I have iterated 1, 2, 3. Now I will check for the fourth node. Now for fourth node, the visited of 4 is false. So if it is false, then I will call BFS utility again. I will call BFS utility and it will perform general BFS. That's all. And I will print 4 in the output screen. Like this, I will modify my function. Now let us code this thing. After coding, you will understand it in a very clear manner. So what I will do is that I will create a function, public static void BFS. In the BFS function, I will pass my array list of edge graph. Now in the function, what I will do is that I will write boolean visited is equals to new boolean of size graph dot length, Now after this, I will run a loop for int I is equals to 0 and I should be less than graph dot length and I plus plus. Here let me give int. Okay, now I will check whether if visited is not true, that is visited of I. If it is false, then I will call my BFS, that is BFS utility function. So utility function, and in this what I will do, I will pass my graph and I will pass my visited array, right? Like this I will do. Now here you can see that, let me copy this thing again. So this, where is my BFS? So I will copy the code of BFS here. Let me remove this. Now what I will do is that in the place on the top of this I will define BFS utility function. Now here along with this I will pass my boolean visited this, and in this I will remove this thing. This is what I'm gonna do. So what I did is, basically I have copied all the things which I have written before, and I have changed the function name from BFS to BFS utility. Now I have created another function called as BFS. In this I have defined visited array, and I am calling for all the elements, I am calling BFS utility function, and BFS utility will take care of BFS, breadth first search. Now in the main function, let me save and remove this thing and call my BFS function. Let me save and run this. So you can see that I got the output as 1 2 3. Like this I will run a loop, and this function, these two functions, that is BFS utility and my BFS will work. This function BFS utility and BFS will work for any graph, whether it is divided into components, whether it is a single graph, it will work for anything, right? I hope you have understood the approach. Now I want you guys to do DFS utility function to perform DFS traversal DFS algorithm for different components. When the graph is dividing into different components, then how you gonna do it, right? I want you to code that thing. Okay, now here in the DFS utility function, what you will do is that change this function to DFS utility and create another function called as DFS, and from this, copy this thing and paste this lines into the new function which you have created. You have created DFS, right? So whatever the thing you have created, copy this 3 lines and paste it there, and change the DFS name to DFS utility. That's all you have to do. I hope you have understood the overall approach, and I want you to code the DFS utility function. So up to now we have studied different traversal techniques like BFS, DFS, and we have did a question called as hash path, and I have introduced you a new concept called as connected components, where my graph is divided into different components, and for those components I have showed you how we code this thing, how we write DFS utility function, BFS utility function, and the lecture is again becoming 1 hour, so I will stop it here, and in the next session we will talk about what is cycle, how we detect cycle, and we will study different algorithms called as a union disjoint algorithm, topological sort, which is nothing but Kahn's algorithm, and other interesting algorithm, and we will study a concept called as bipartile graph. So with that being said, the next lecture is going to be very crazy and interesting one. So with that being said, I will see you in the next one.